Congratulations, Mr. Serpico here this morning. I'm going to take you through a little math activity. So today we're going to take a virtual tour through the prisms and pyramids of Egypt. Well, maybe not, but we are going to take a look inside your math textbook. So it starts off with describe a solid figure by its faces, edges, and vertices. A plane figure is a flat or two-dimensional surface. It has only length and width. Polygons are plane figures. Most of the objects around us are solid figures and three-dimensional. So if you're thinking about a three-dimensional figure, look around your room right now. It's going to have those three dimensions, length, width, and height. Here's a great example. Think of maybe a sugar cube or a Rubik's Cube. Okay, so this is about where we left off. We were talking about this cube, how it has a square face, and then any one of these faces can be considered a base. The top and the bottom face of a solid are called bases. The base of a cube is a square. So if you rotated this cube, think of it as a die, you roll that, it could land on any one of those bases or faces. And they have square faces when you're talking about a cube. Let's keep going here with some three-dimensional shapes. Probably the most common one right here is the cube. Okay, as I scroll down here a little bit, you'll see a cube has edges and vertices. So these vertex, plural is vertice. An edge of a solid figure is a line segment formed when two faces meet. So this is considered an edge where these two faces meet. And the vertex is where three or more edges meet. And again, the plural of vertex is vertices. So again, you can see right here, this is an edge. You got a vertex here, vertex here, vertex here, vertex here, vertex here, vertex here. A cube has 6 faces and 12 edges with 8 vertices. Let me count those vertices for you so you can see these little black dots. 1, 2, 3, 4, 5, 6, 7, 8. And again, you can see this little dotted line in here indicates one of the edges. All right, moving along, talking about prism. A prism is a solid figure with 2 parallel or congruent bases joined by rectangular faces. Prism is named according to the shape of its bases. So prisms are named after their bases. The bases of a prism are rectangles. This one we're about to look at, that is, this prism is called a rectangular prism. And you have the think aloud from the little girl here. Congruent bases mean the bases have the same size and shape. So if you look at this, I think of like a tissue box, a rectangular prism, or perhaps a cereal box flipped over. You've got the rectangular faces all around. You've got the bases are kind of colored in a reddish color, maroon color. And you've got your rectangular bases. You've got your vertices. It's the same number of vertices as a cube. Okay, so there are 8, 1, 2, 3, 4, 5, 6, 7, 8. And then the opposite pair of faces right here, where it sits, can be considered the base. And then these side faces will be considered just that, a face. You've got your edges, and this is a little bit more of a complex figure. Again, we're going to name the prism after the base. The base of this prism is a triangle. So this base and this base would be considered triangles. Again, we're going to walk you through. You've got your edges. You've got vertices in this three-dimensional figure, just like any three-dimensional figure. And then you can find pairs of faces and bases in this triangular prism. This triangular prism has 5 faces, 9 edges, and 6 vertices. All right. So what would the name of this prism be? Take a minute to look at it and think about it. What are these arrows pointing to? Can you name the parts of this prism? Can you think about what shapes the bases are? What shape does this look like? What shape does this look like? And remember, prisms are solid figures with 2 parallel and congruent bases joined by rectangular faces. So you see the rectangles going around this figure, and then the 2 bases that are congruent, so they're same size and same shape and parallel to each other. So as you study this 3D figure, think about how you could look at the different components and try to identify different things. Okay, so here's a vertex, right? It's where 2 lines or 3 lines meet. Over here, this is a flat face, all right, parallel to another, or congruent to another rectangular face, rather. What else is going on in this figure? I used a magical pen. I gotta pick one of these more permanent pens. That's my mistake. So you got vertex face, as we said. Now you've got an edge here, and over here you've got the base. And I know this is the base because these 2 are parallel and congruent to each other. Oh, this auto edit is changing this word face to force. That's my handwriting issue. Let me fix that. So we're not going to go back to motion and design here with forces. Let's stick with 3D geometry here, Todd. So this is a face. And if you haven't said it to yourself yet, you probably already knew that these 2 faces are pentagons. Okay. Pentagonal prism. Pentagonal prism is what we're looking at here. So remember, we name our 3D figures after their bases. Take a look at the base of this and then how it comes to this one vertex here. What do you think a figure like this would be called? You've got that apex, vertex. If you didn't say it yet, it is a pyramid. So a pyramid is a 3D figure that has one base that can be any polygon, really. All the other faces are triangles in a pyramid arising from each side of that base. The triangular faces share a common vertex, and a pyramid is named according to the shape of its base. So this is a rectangular pyramid or a square pyramid. All right, it's a square at the base, and it came to one apex vertex here. And then you can clearly see this is a triangle, this is a triangle, all the different sides are triangles. All right, so I bumped ahead here. This base of this pyramid is a triangle. So this would be called a triangular pyramid. So your base is a triangle. You've got your faces are also triangles, comes up to a vertex. So let's go back and try to diagram one of these pyramids and name it. So you've got a base, it's a pentagon. Try to remember what these things are here. If you want to try to even draw it in your notebook, now would be a good time to pause and give that a shot. Pyramids are tricky to draw. I like to draw the base first and then the vertex. I'll do a demonstration on how to draw a pyramid. I'll do a demonstration rather on how to draw a pyramid soon. But for now, let's diagram this. You probably finished doing so. So you've got your vertex. You've got a face here. Down here, you've got another example of a vertex. Over here, you've got a base. Auto edit's going crazy on me today. Sorry, kids. So over here, this could be pointing to either an edge or maybe this face. And this is pointing to an edge. I think this is more of an edge here that they're trying to show you because of that, where that black line goes. All right, probably face isn't the best choice for this one. This also looks like it's pointing to an edge. All right, now it's your turn to practice. So give it a shot. Hop into your workbook. Pages 193 to 195 will give you some great opportunities to practice with these three-dimensional shapes. Labeling figures, faces, edges, vertices, different types of pyramids, and three-dimensional shapes. Thanks for your attention today, kids. Have a great time.